It's the kind of question that sort of breaks your brain when you even start figuring out how to think about it. What shape is the universe? No one can be sure. Until we can step outside the universe and walk around it somehow, we can't actually do that ever, the best we can do is to take what we know to model the likeliest scenario. The idea of the shape of the universe comes down to key insights from general relativity that say mass warps space-time, and that objects moving through space have their paths curved. Here's a simple way to think about it. Imagine there's a bowling ball on a trampoline. That's the sun warping space around it. Now roll a marble past the bowling ball to mimic a planet in orbit. From the marble's perspective, it's rolling in a straight line, but we can see that its path is curved by the bowling ball depressing the trampoline. Now imagine that the universe is a giant trampoline covered in bowling ball stars, medicine ball black holes, and little planet marbles. This means that masses are warping space all over the place, and the combined force of all that mass has the capacity to shape the universe. So really, when we talk about the shape of the universe, we're talking about the density of the universe. The simplest shape to get your head around is the flat universe, which isn't flat like a two-dimensional piece of paper, it's flat because it has no curvature. This is the shape the universe would take if it has the exact amount of mass to stop the universe expanding after an infinite time. It will have no bounds and expand forever, slowing but never stopping. If the universe contains more mass, more than critical mass, so enough to stop its expansion, it will have a positive curvature. In this scenario, the universe is closed and looks like a sphere. It would be finite but without a beginning or end. Eventually, the mass will cause the universe to collapse back in on itself. If on the other extreme the universe has insufficient mass to stop its expansion, it will have no bounds and expand forever in an open shape, sort of like a saddle. So which is it? Well, current cosmological observations say the universe should expand forever, so the positive curvature isn't likely. But it also doesn't seem to have the right conditions for negative curvature. Data from NASA's Wilkinson Microwave Anisotropy Probe mission of distant supernova show that the universe's rate of expansion is accelerating, but that rate is balanced by the mass of dark matter. In short, the universe is likely ever so nearly flat. But it's possible that that's the observable universe. Because the speed of light is a fixed value, we can only see 13.8 billion years back. It's possible we just can't detect a complete curvature with the instruments we have, or in ways that the laws of physics will allow. So while we all know the Earth isn't flat, it looks like the universe almost is. Thanks to Domain.com for sponsoring this episode of Seeker. When you buy a domain name from Domain.com, you're taking the first steps in creating an identity and vision for your brand. No domain extension will help you tell your story like a .com or .net domain name. Get 20% off Domain.com's already affordable domain names and web hosting when you use the coupon code SEEKER at checkout. It's been almost 4 years since I started here, and I've loved every single episode, especially that awkward, naked, cold open, and fun times with chimerism. But I've got some exciting new things in the works, so I'm not going to be around Seeker as much. I'm still doing vintage space, so if you want to keep up with me and see what I've got going on, and also tons of Pete pics, be sure to follow me on YouTube as well as on Twitter and Instagram. And of course, be sure to subscribe for more Seeker. Thanks so much for watching and for 4 years of awesome science content. Oh.
She's this short.
Oh, I'm gonna miss seeing you guys all the time.